Welcome to Brain Vision.
Problem 7.63. We have a block of ice on a frictionless table. It's compressing a spring. The table's height is 1.2 meters, and then the block is going to be released and fly off the table and hit the floor. And we want to know how fast the block is going when it does that. So this is a fairly straightforward conservation of energy type of question. So initially, we have potential energy, both gravitational. If we call this y equals 0, and this y or h will be 1.2 meters, whichever, y or h, whatever. And then the energy stored in the spring, nothing is moving, so there's no kinetic energy. And then at the end, it's at the floor level, so there's no gravitational potential energy, and the spring is long since been left behind, so there's no elastic potential energy, no potential energy in the final condition. So we have 1/2 mv squared is equal to 1/2 kx initial squared plus m gh, where h, recall, is 1.2 meters. So then if we solve this for v, we'll have the square root of k xi squared over m plus 2 gh and this evaluates to 7.01 meters per second.